Welcome everyone back to SAT Math Question of the Day, where we go over how to do SAT questions, but more importantly, how to approach them. We have Professor Emeritus Seth Chaiken at University of Albany, his brother Joel Chaiken. Seth is a professional mathematician. He has his PhD in math. So he's going to say something about this question. I have not read it yet, which is good because I like to do problems cold so that you see how to struggle with them. It's sort of a fraud when you have someone who's already seen the question help you with it. Although Seth already seen the question, we won't call him a fraud. Okay, the sales manager of a company awarded a total of $3,000 in bonuses to the most productive salespeople. The bonuses were awarded amounts of $250 or $750. If at least one $250 bonus and at least one $750 bonus were awarded, what is one possible number of $250 bonuses awarded? Oh, it's a word problem. No calculator, and you have to give an actual answer. No.
Okay. So the numbers, what we should note is that the numbers that it refers to are whole numbers.
Right.
Yeah. Okay.
So, well, you know, at least $1,000 was. You could take $1,000 right off the table, right? Because
right.
At least one $250 and one $750.
Yeah.
When you deal with word problems, you got to feel them. You got to really understand the novel. It's like a tiny little novel, and you really got to understand the novel. And once you understand the novel, you can start doing it. So at least one of these. So you want to take at least $1,000 off the table. So you're dealing with $2,000, right? 3,000 minus 2,000.
Okay.
Now, what is one possible number of $250 bonuses awarded?
Okay.
I mean, doesn't this...
So we have an equation. Yeah. What is 2,000 equal to? Well, I'm inclined to use algebra. I'm inclined to define two variables for the number, one for the number of additional 250 bonuses, and another variable for the number of 750 bonuses.
Okay. So
let's be careful. Since 250 is a small bonus.
T for 2 and S for 7.
Okay, yeah. Okay, number of additional.
Well, we know that already.
No, we have to be careful because once we figure out what T might be, we have to add 1 to give the answer.
Wait, let me read that.
We must remember to include in the number of 250. Yeah. So in order, we want to compute the number, a possible number of 250 bonuses. If we take $1,000 off at the beginning, one pitfall is that we might calculate a possible number of 250 bonuses that are over and above the one that we took off.
Tricky.
And so we have to remember to add 1 once we figure out what T and S are.
They really should have put what is one possible number of total 250 bonuses awarded. They really should have said that. But they didn't. Oh my God, you got to really be careful there. Ooh, ouch.
Okay, so these are additional.
Right.
And then let's what you might do is remind yourself by writing that the answer equals T plus 1.
Yeah, but nobody in practice is going to do that on the SAT because you're not going to have time. But you do have to.
Well, you have to. No, it may be a good idea to do that. It's even on the SAT.
Okay, fine. I mean, it's everyone's personal choice, but I think 99% of the people are not going to have time to do that.
And then they'll forget to add 1.
There does it at least gets it in your head. Okay, so now what do you do?
So what's the equation?
Well,
it's 250 times T plus 750 times S.
S, right.
So we have to find a possible integer for t for which there's an integer for s that makes the equation true.
Right.
Well, the first thing I would do is, since it's a problem dealing with integers, if we divide both sides by 250, we have smaller numbers to deal with.
Yeah, but then.
No, let's do it. So let's do it. 200 divide by 250, and we get t plus 3s, and 2,000 divided by 250 is 8.
It's 8.
Is 8. So this is a lot easier.
That's true.
Figure out a value of t and a value of s, such that if you add t with 3 times s, you get 8.
Right. And the rule here is, we should put it down, but you'll know it in your head. S and t must be integers, right?
Yes.
Must
whole
be. And
numbers.
Integers.
Yeah.
Must be. This is critical.
And not negative, not just integers, but positive. Come on. Positive or zero integers.
Yeah, but you don't have to go nuts.
Okay.
Must be integers.
Okay.
Everybody knows those. Everybody's common sense.
Okay, so let's see. What's a possible value for t? Maybe 0. Why cannot t be 0?
Because then you can't get enough 750s to make 2,000.
No. If t were 0, 8 would have to be a multiple of 3.
Well, that's what I said. S can't
Which
be
it
an
isn't.
integer. S can't be an integer. If t is 0, S can't be an integer to solve this equation.
Well, we're talking about what s is. The choices for s are just integers.
Yeah.
So simpler to think, if t equals 0, it's an integer. Is it possible for 3 times an integer equal 8?
No.
And it isn't.
It's not. Of course not.
Okay, so t we ruled out 0.
Right.
What about 1?
Yeah, 1 doesn't work either. It doesn't work either.
Well, let's see.
No, it doesn't work.
If t is 1,
work.
Work it out. If t is 1, then 3 times s has to equal 7, which is also impossible.
Right. Or you take 1 to the other side. Right, yeah, 3s.
Yeah. You just put it in. You put it in.
Yeah.
8 equals 1 plus 3s, so 7 equals 3s.
Right.
How about 2? If t equals 2, well, the 3s is an odd number, but it might be 0. Okay? So s might be 0. T might be 2, which it can't be.
No.
Or can t be 2? Can t be 2? Hold on. Can t be 2? Hold on, listen. Can t be 2?
Of course t.
If t is 2, then 8 equals 2 plus 3s.
Right.
Therefore, the only possible way it could be solved is if 6 is equal to 3s.
Yeah, which it is.
Well, that's possible.
Of course.
By taking s equal 2. So we found the answer. 2 is one possible number. Except that the answer is 2 plus 1.
Yeah.
So the answer is 3.
Right, the answer is 3.
Yeah.
Yeah, that's right. Good. That was a really smart way of doing it.
Yeah.
I doubt most people would divide by 250. The way I sort of did it was, 750 is a very common number, and just sort of by looking at it, if you have only one 750, like there's really no way to get enough 250s.
Yeah. Oh, yeah. That's a cool.
But the thing is, 750 times 2 is 1,500.
Yeah.
It's 50, right? 750 times 2 is 1,500, and we know the difference between 1,500 and 2,000 is 500, and 500 is easily divisible by 2.
Okay, cool.
Oh, yeah.
That's another way to see it.
No. My brain actually did it in parallel, which is a great way to do these problems. I sort of looked at this, and it's amazing how the human brain can think in different ways at the same time. And I sort of got a sense, 750, double it, 1,500. 1,500
cool.
minus 2,000 is a cool number. But the brain also had to keep an eye. It's like driving, right? When you're driving, most people aren't driving it, but when you're driving, your brain's got to do a lot of stuff at the same time. And it's similar thinking, right? You sort of see the 250, you just sort of see the answer. But Seth did it a lot more methodically. And of course, Seth divided.
No, I really like the idea that you start with S. And you using the fact that 750 is a big number, and so that limits what S could be. S cannot be 3.
That's right. S cannot be 3.
So S can either be 0. S could be either 0, 1, or 2.
Yeah, S can be 0.
If S is 0,
then it works. You can do it.
Then T could be 8.
Yeah, you're right.
So another answer is T is 8, right?
Yeah.
So we have to add 1. Don't forget to add the 1.
Right. So the final
8 plus 1 equals 9. So this is a case where you write in an answer, and there are 2 correct answers.
Right.
So S could be 0. S cannot be. Can S be 1?
No, I don't. Maybe.
Yeah,
S could be 1.
S could be 1.
But it's a hard. S1 requires too much brain power to calculate.
Yeah. And S could be 2.
S could be 2 is an easy one. S is 1. We won't even do it, but it requires too much brain power.
Yeah.
Unnecessary brain power.
So is there another answer?
Yeah, S. That's right. S can be 1.
Let's see. So 3. Well, T equals. T. Okay, the answer is 9 if S is 0.
Right. And if S is 1, there's an answer.
If S is 1. T could be 5.
5.
And if S is 2, T could be 2.
Yeah. So the final answers are 3, 9,
so
or
6. It could be 6. Well, we got 3 already.
Yeah, 3 answers. Yeah.
So the 3 answers. So indeed, it is a good idea to given that the coefficient of S is bigger than the coefficient of T, we have to. That's a very good strategy because in order to fit 250s into 2000 with a big in order to fit 750s into 2000, you have to limit the number of 750s.
Right.
So that reduces the number of cases you have to look at. So noticing that 750 is big, or if you divide it out by 250, noticing that 3 is big compared to 1, that leads you to search for the answers, not the way I did by considering possible values of T, but to consider possible values of S.
Yeah, right. But again,
I was led to look for possible values of T because the problem asks for a possible value of T plus 1. So that's why I started with T.
Right.
And of course, it worked. Either way.
There are a lot of different ways. There's a lot of different ways to do this problem.
Yeah. So it's a strategy one should remember for SAT questions is always keep in mind what is the question.
Well, of course. Yeah. That's a big thing.
But sometimes the question can be answered more efficiently by finding an answer to a different question.
Right. That's where the parallel thinking comes in. That's where you got to be open and prepared for everything. When you're driving, you got to be ready for some car coming out of nowhere. You got to do this parallel thinking sort of thing, which is hard. The other thing about this is that I think most people, there's a good percentage of the people who will understand how to do this and still get the wrong answer. And I would say there's a pretty good percentage of people of the people who understand how to do this, they'll still get the wrong answer because they'll answer the number of additional 250 bonuses. They'll forget to add the 1.
Yeah.
And that sort of goes in the theme of them really trying to trick you. Okay, which I hate. I hate that stuff. But be prepared for these questions on the SAT where there's a trick involved. I hate these things.
Yeah. Well, another approach is to not choose for your variables the number of additional bonuses, but use for a variable the number of bonuses.
Right,
and then include the condition. Let's say called T prime.
Seth, nobody's going to do that.
And S prime are the number of bonuses. We could add a condition that each of these has to be greater than 0. And then we search for the answer only among T primes and S primes that are non-zero and positive.
I have no idea what you're talking about.
So in other words, an alternative approach.
Wait. Let's say goodbye to everyone, okay? Because this is going to get nasty. Okay, everyone. If you want to hear the alternative approach, stay on. But it's probably fine. I think we're done. Please like us, dislike us, comment. All comments are encouraged. We need feedback to know how to help you. Seth is dying to tell us what the alternate approach is. He totally lost me in what he said, so I'm sort of interested.
Well, I'll detail it.
And it doesn't help that the page is a mess.
Yeah.
Okay, everyone. I'll see you later. Have a great day. Stay on if you want to hear the additional approach.
Okay, so I'm using reds. So instead of using this equation where you took the 3,000 off at the beginning, we change it to the equation that expresses directly what the problem is. And then we use different variables. And then we combine this equation with the conditions that T prime is greater than 0 and S prime is greater than 0. And as before, we search for possible values of S prime. And so what we would do is start with S prime equals 1. And indeed, that gives an answer. And indeed, if S prime equals 1, what you have left over is $2,500. And so T prime becomes 10. No, it becomes 2,250, right?
Which is 9.
Yeah, so which makes T prime be 9, which gives you that answer. So you can do it that way too.
Right? Yeah. That I can't believe most people would do that. It just
it depends on how they were taught. I presume you're the one that's connected with this, but I presume these kinds of problems, which mathematicians call Diophantine equations, are part of the curriculum.
Yeah. Most of the way this question almost never comes up. The way you normally see this is some sort of inequality problem. Where what's the minimum number of things you need? This is where you'll find in SAT problems that most of these SAT problems you've never seen before. They're asked in a way that you've never actually seen before in class. They want you to think a little. They want you to understand what's really going on and think. And that's why most of these questions are not questions that you would have actually ever seen in your life before. So So there we go.
Well, when you formulate it this way, you do have a problem including inequalities.
Yeah. Okay. So okay, great. Okay, have a great day, everyone, and we'll plan to be back tomorrow for another SAT math question of the day. Have a great day.